Let's talk about simplifying radical expressions. Now, for the duration of this video, we are going to assume that all variables represent positive real numbers. We'll talk a little bit about negative numbers in a future video. But making this assumption simplifies the steps that we're going to do quite a bit. So we're going to make this assumption because it makes our life easier. All right, so let's suppose that we have a radical expression. It looks something like this. And we want to simplify. What would it even mean for something like this to be simplified? Well, for something like this to be simplified, the big thing that we want is we want to have as little as possible inside the radical. This is a lot like what we meant when we were saying we were simplifying square roots. And just like when we were simplifying square roots, we're going to need some tools. In particular, we're going to need the following. For any positive integer n, the nth root of a product is the nth root of the first thing times the nth root of the second thing. We're also going to use this fact. For any positive integers n and k, the nth root of a number to the n times k power is just a to the k power. Right, that makes sense, doesn't it? That means, for example, the cube root of 2 to the 6th is just 2 squared. In other words, the cube root of, what's 2 to the 6th? 2 to the 6th is 64. That's just, well, the cube root of 64, that's 4, which is 2 squared. Yeah, that works out. It makes sense, right? If I multiply this by itself 3 times, well, I'll get 3 times as many 2's. No problem. And then there's one more thing that we're going to do that we didn't bother with when we were simplifying square roots of numbers, but now that we have higher radicals, this is worthwhile. If we have numbers inside of radicals, we'll factor them into primes and then treat them like variables. So now we have all of the groundwork in place. Let's see how we simplify a radical expression. And I'm going to give you a simple example first. Let's say we want to simplify the cube root of x to the 7th. Now, 3 doesn't go into 7. 7 divided by 3 is 2 1/3. So the question I want to ask myself is, what multiple of 3 is closest to 7 without going over? Easiest way to figure that out is count 3, 6, 9. 9 goes over, so 6 is closest. So here's what I'm going to do. I have the cube root of x to the 7th. I'm going to write x to the 7th as x to the 6th times x to the 1. Right, I can do that because 1 plus 6 gives me my 7 back. And now, using this rule, I'm going to write that as the cube root x to the 6th times the cube root x to the 1. And I'm carrying this 1 around just for the moment. I'll stop writing it eventually. Now using this rule, and noting that 6 is 3 times 2, the cube root of x to the 6th is x squared. Cube root of x to the 1st I can't do anything with. So I have x squared cube root x. And this is my simplified form. Right, so notice, what's outside the radical? The stuff I already did cube root to. What's left inside? The stuff I didn't do cube root to. So I'm going to have you try one of these. Simplify the fifth root of u to the 19th. Pause the video and try this one now. All right, so multiples of 5. 5, 10, 15, 20 goes over, so 15 is the closest. And you don't need to write this down, but this is what we're thinking. So we're going to say that the fifth root of u to the 19th is the same as the fifth root of u to the 15th times u to the 4th. So that's the fifth root of u to the 15th times the fifth root of u to the 4th. 15 is 5 times 3. So the fifth root of u to the 15th, that's u to the 3rd. And then the fifth root of u to the 4th, I can't do anything more with. And there I am. All right, let's see how this works with numbers. Let's suppose we want to simplify the cube root of the number 108. All right, now, we could, if we liked, kind of rummage around and see if we can find any perfect cube factors, but it's simpler to just factor this guy into primes. 108 is an even number, so I'm going to divide out a 2 first. 108 divided by 2 is 54. 54 I know is 9 times 6. 9 is 3 times 3. 6 is 3 times 2. And 2 is prime. So 108 is 3 cubed times 2 squared. The cube root of 108 is the cube root of 3 cubed times 2 squared. And now I look at each of the exponents. Well, multiple of 3 that's closest to 3 is 3. And there are no multiples of 3 less than 2. So I'm just going to split this up as cube root 3 to the 3rd times cube root 2 squared. 3 is 3 times 1, so this is just 3. And then we've got cube root 2 squared is 4. The cube root of 108 simplifies to 3 times the cube root of 4. I'm going to give you one of these to try as well. Simplify the fourth root of 160 by first factoring 160 into primes. Pause the video and try this now. All right, so 160, the most obvious pair of factors are 16 and 10. 6 is 4 times 4. 16 is 4 times 4, so it's 2 times 2 times 2 times 2. 10 is 2 times 5. So I have 2 to the 5th times 5. This is the fourth root of 2 to the 5th times 5. All right. Multiple of 4 that's closest to 5 without going over is 4. So this is going to be the fourth root 2 to the 4th times 2 times 5. So this is going to be the fourth root 2 to the 4th times the fourth root 2 times 5. 4 is 4 times 1, so the fourth root of 2 to the 4th is 2 to the 1st. 2 times 5 is 10. So this is 2 times the fourth root of 10. Okay, now that we know how to deal with all of the objects, Let's see how we would go about simplifying that complicated thing that we saw at the beginning. So we want to simplify the fifth root of the expression 128 times x to the 17th times y to the 14th times z to the 12th times u to the 3rd. And we're going to start by breaking down 128 into primes. 128, well, that's an even number. It's 2 times 64. Oh, I see where this is going. 64 is 8 times 8. And each 8 is 2 times 2 times 2. So how many 2's is that? 1, 2, 3, 4, 5, 6, 7. So we have the fifth root, 2 to the 7th, x to the 17th, y to the 14th, z to the 12th, and u to the 3rd. Now for each exponent, we're going to find the closest multiple of 5. Why 5? Because we're taking the fifth root. Let's see. And I'm going to write these down. You don't necessarily have to. For 7, the closest root is 5, which is 5 times 1. For 17, 5, 10, 15, 20 is too big. So for 17, the closest multiple of 5 is 15, which is 5 times 3. For 14, the closest multiple of 5 is 10, which is 5 times 2. For 12, same story, 10. And for 3, there are no multiples of 5 less than 3. So we've got nothing for 3. So using this, I'm going to rewrite. I'm going to have the fifth root, 2 to the 5th times 2. 5 plus what is 7? 5 plus 2 is 7. X to the 15th times x to the 15 plus what is 17? 15 plus 2 is 17. Y to the 10th times y to the 4th, because 10 plus 4 is 14. Z to the 10th times z squared, because 10 plus 2 is 12. And u to the 3rd just sits there. All right, now I'm going to sort the exponents that are multiples of 5 out from the exponents that aren't. So I'll have the fifth root 2 to the 5th, the fifth root x to the 15th, the fifth root y to the 10th, the fifth root z to the 10th, and those are all the multiples of 5. And then what's left? I'll have the fifth root 2 squared, x squared, y to the 4th, z squared, u to the 3rd. I can put everything that's left in one radical, because this is what's going to be the radical part in my answer. So now the fifth root of 2 to the 5th, of course, is going to be 2. The fifth root of x to the 15th, 15 was 5 times 3, so this is going to be x to the 3rd. The fifth root of y to the 10th, 10 was 5 times 2, so this is going to be y squared. The fifth root of z to the 10th, 10 was 5 times 2, so this is going to be z squared. And then I'm just going to copy what's left, except 2 squared, that's 4. And that's what we get when we simplify this. I'm going to give you one of these to try, a long, complicated one. Simplify the cube root of 432 times x to the 11th times y to the 9th times u to the 8th. Pause the video and try this now. All right, so we're going to start by factoring this number into primes. And that looks kind of complicated, but I know that it's an even number, so I'm going to factor out a 2. Dividing by 2, I'm left with 216. That's still even. Dividing by 2 again, I'm left with 108. I happen to know that 12 goes into 108. 108 is 12 times 9. 9 is 3 times 3. 12 is 3 times 4. 4 is 2 times 2. So my 432, I have 1, 2, 3 threes, 1, 2, 3, 4 twos. So my 432 is 2 to the 4th, 3 to the 3rd. So I have the cube root, 2 to the 4th, 3 to the 3rd, x to the 11th, y to the 9th, u to the 8th. Okay. The closest multiple of 3 to 4 is 3. So I have 2 to the 3rd times 2 to the 1. The closest multiple of 3 to 3 is 3. So I'll leave it as 3 to the 3rd. To 11, 3, 6, 9, 12. 12's too big, so it must be 9. X to the 9th times x squared. 9 plus 2 is 11. 9's a multiple of 3, so I'll just stick with y to the 9th. 8, 3, 6, 9. 9's too big, so I'll have u to the 6th, u squared. Now I'm going to pull out all the perfect cubes, all the powers that are multiples of 3. Cube root 2 cubed, cube root 3 cubed, cube root x to the 9th, cube root y to the 9th, cube root u to the 6th. I notice I'm colliding with my work over here, so I'm going to write a times sign and put the leftover stuff on the next line. What's left is a 2, an x squared, and a u squared. All right, so what do I have? Cube root of 2 cubed is 2. Cube root of 3 cubed is 3. Cube root of x to the 9th, 9 is 3 times 3, so I have x cubed. 9 is 3 times 3, so I have y cubed. 6 is 3 times 2, so I have u squared. And inside the cube root, I'm left with 2x squared u squared. I'm almost done. All I have left to do is multiplication with numbers. 2 times 3 is 6, and then I've got x cubed, y cubed, u squared, cube root 2x squared, u squared. And that's all there is to it.